We have a third example here. Use Kirchhoff's laws and Ohm's law to find the voltage V0 as shown below. Then the B part says, show that your solution is consistent with the constraint that the total power developed in the circuit equals the total power dissipated. So here is the solution here. We can see that we have IS is unknown, I0 is unknown, and what else is unknown? V0 is unknown. So we have three unknowns. And we need to find the values of those unknowns. In this circuit, you can see we have an independent voltage source here. Here is a voltage source, and this is a dependent voltage source. And as you can see, this is 3Is. Because of this is a current controlled dependent voltage source. Current controlled voltage source is what we have here. And then we have our V0. Okay, let's try to analyze this circuit. So if we carry out KVL around this left loop, what we do have is minus 10 plus 6Is, because the current passing through this resistance is going to be Is. The voltage then becomes 6 multiplied by Is according to Ohm's law, which is IR. Ohm's law states that V equal to IR. I is Is, R is 6 ohms. So voltage across this resistance is going to be 6 times Is. Therefore, applying the voltage law, the KVL, gives us minus 10 plus 6 Is equal to 0. That's exactly what we have here. At the second loop, which is the right-hand side loop, you see that the voltage here is going to be 3Is. If we use our voltage conventions and concept to analyze this, it becomes minus 3Is plus 2I0 plus V0 equal to 0. By the way, V0 will be equal to these 3 ohms multiplied by the current flowing through this resistance, and that current is I0. So V0 is equal to 3I0. So we can easily say we have minus 3Is plus 2I0 plus 3I0 equal to 0. And that is exactly what we have as equation 2. And I've already told you equation 3 already. Our V0 is equal to IR, which is going to be equal to I0 multiplied by 3 ohms, because I0 is the current flowing through this particular resistance. So V0 equal to 3I0. That's our equation 3. If we solve these 3 equations simultaneously, we would obtain our Is equal to 5 over 3. From equation 1 alone, our Is will be equal to 5 over 3 if we make Is the subject of the expression here. So Is becomes 5 over 3 amperes. From equation 2, we find out that our I0 is equal to 1 amperes, because this becomes 2I0 plus 3I0. This becomes 2I0 plus 3I0 becomes 5I0. We know our Is to be 5 over 3. If you put that in here and then you make I0 the subject of equation 2, you obtain I0 to be equal to 1 ampere. From equation 3, since we know our I0 already, our V0 will be equal to 3 volts. We just multiply 3 by the value of I0, which is 1 ampere, and that gives us 3 volts. That solves the A part of this question. Then the B part says, show that your solution is consistent with the constraint that the total power developed in the circuit equals the total power dissipated. We mentioned this earlier, that total power developed in the circuit must be equal to total power dissipated in that particular circuit. So it simply means that we have to find the power dissipated by each of the elements we have. So we have 2 voltage sources where power will be generated. So power will be generated at this 10 volt, the 10 volt source, and then the 3Is voltage source. So power at a 10 volt source would be equal to IV. Power is equal to current multiplied by voltage. So what is the current? The voltage is 10 volts. We had said that when current is entering a voltage source, it means power is consumed. We're going to use a positive value for our current when calculating the power. And then we had also said that when current is leaving a voltage source, we are going to use a negative sign to represent the current when trying to calculate power. So what you will see here is current is leaving this voltage source. That simply means that we're going to represent this current. The power is going to be negative because the current is leaving. It's going to carry a negative sign. If you have not seen the previous lesson, please go and check the previous lesson and understand how we explain the basics of assigning positive sign or negative sign to power when analyzing a circuit. So since the current is leaving this circuit here, we assign a negative value to the current. It becomes minus Is multiplied by the voltage 10 volts, and that gives us the value of the power across these particular voltage source. So P around 10 volts will be equal to minus Is times 10, and then our Is is found to be 5/3 already. If you multiply that by 10, that gives us minus 50/3 watts. So you keep that somewhere. Also, we go to the voltage source on the right hand side loop, which is a current controlled voltage source. You also see that the current is leaving this particular voltage source. So therefore, we will use a negative sign for this current I0 when needed. So we know that our current, our power will be equal to IV. Because the current is leaving this voltage source, it becomes minus I0. So that is why we have minus I0 here. Then we have multiplied by the voltage, which is 3Is. We found our I0 to be 1 ampere, and then we found our Is to be 5/3. If you put all of those in this expression, your power at this element would be equal to minus 5 volt. You will see that we have minus here, we have minus here. That tells you that power is generated as explained in the previous lesson. Please go and look at the lesson so that you can add that to your understanding. Okay, the very first lesson that we had about this teaching. We have 3 other elements in the circuit, and we can easily find the power dissipated in those elements. Okay, now these are not sources. So as you can see, current is going into the 6 ohm resistance. So this is certainly will know that since current is going into this particular resistance, this particular circuit element, it means that power is going to be consumed in this circuit. Current is also going into this 2 ohm circuit element. Power is going to be consumed in this circuit. Current is also entering this particular circuit element. Power is going to be consumed by this circuit element. For these 6 ohms, the power consumed for the 6 ohms would be equal to I squared R, because we are dealing with resistance here, so it's better to just use the formula for power that has with just I and R. So we have I squared R. We know what our Is is because this is our current passing through here. We know Is and then we know R. So Is squared multiplied by R, which is 6, will give us 50/3 watts. So we keep that power. The power consumed by these 2 ohms will be equal to another I squared R. I0 squared in this case multiplied by 2. I0 is already found, so we multiply that by 2. We squared that and multiply it by 2. That gives us the power consumed by the 2 ohms resistance. And then we go to 3 ohms resistance, and then we also find the same thing. For the 3 ohms resistance, we have I0 squared multiplied by R, which is 3 ohms. That gives us 3 watts. All of them have positive signs, and that tells you that power is consumed by those circuit elements. Okay, so power generated by this circuit element is equal to minus 50/3, and power consumed by the circuit element is also 50/3. If you add all the powers, because we had said at the beginning in the previous lesson lecture, we had said that sum of all the algebraic sum of all the power in a particular circuit in a circuit is equal to 0. In a closed path or in a circuit is equal to 0. So in this particular circuit, algebraic sum of all the power in this circuit is expected to be 0. This is minus 50/3. This is 50/3. If you add those together, that gives us 0, as you can see here. Here we have 2 watts, we have 3 watts, and then here we have minus 5 watts. If you add all of those together, the total power would also be equal to 0. And that simply means we can prove that total power dissipated is equal to total power generated. I encourage you to go over these again and again, watch this video again and again, check this lesson again and again, so you can solidify your understanding about all the concepts that is being explained. Here we have another simple example we can quickly look at. The current I file in the circuit shown is 2 amperes. So I file is 2 amperes. Calculate A, Vs, which represent voltage source, and B, the power absorbed by the independent voltage source. This is the independent voltage source, so find the power absorbed or consumed by the independent voltage source. The power delivered by the independent current source. So what you will find out here is that this is the independent current source, 5 amperes. What is the power delivered by this independent current source? The power delivered by the controlled current source. This is the controlled current source. What is the power delivered by this particular source? And then the total power dissipated in the two resistors. Okay, let's begin. So you will see that I file is given. We have that as 2 amperes in the question. I1 is not known, and then Vs is not known. So we have 2 unknowns. We are going to use KCL and KVL to solve this problem. If we use KCL around this particular node, we can say the current going into the node should be represented with a negative sign. So this becomes -5. You can see that's why we have -5 here. Current leaving this node is I file. I file is leaving this node. That becomes plus I file. That's why we have plus I file here. You can see that another current leaving this node is 2 I file. If you go through this particular path, 2 I file is the current leaving this particular node. So you can see we have plus 2 I file according to our sign convention. I1 is also leaving this node. So you can see we have plus I1 here. So this gives us equation 1 using KCL around this particular node. Then equation 2 using KVL. If we use KVL, as you will find out, we can have our clockwise movement this way, and then this is going to be our clockwise movement. And if we have a clockwise movement, the path will be moving this way. So that path, you will find out that it is against the movement of current. I file is flowing down, our path is flowing up, because I file is flowing against the path that we have created. The voltage across this circuit element, this resistance, will be IR, and the R is 30, I is I file. If you multiply both, it becomes minus 30 I file. That is why we have minus 30 I file here as a voltage across this circuit element. And then we continue with the 10 ohms resistance. What you will find here is that the current in our the flow of our path is in the same direction with the flow of current through the 10 ohms resistance. So that simply means this voltage is going to be positive. So we have I is I1 and then R is 10 ohms. So that gives us plus 10 I1. And then since the path we created, the flow of current path we created will be traversing from positive to negative on this voltage source, the value of the polarity of this power, the power absorbed or consumed by this voltage source, will be positive. So this becomes plus Vs equal to 0. That gives us equation 2. All right. So we know our I file is 2 ampere. We can put that in this equation, and then when you do that, all we're going to have left will become I1 equal to 5 minus 3 I file, and then we have minus 1 ampere. So we can easily find our I1 using equation 1 as minus 1 ampere. Then from equation 2, since we know I1 already, we can put that in equation 2 and find our Vs, and that gives us 70 volts. So this solves the A part of the question. Then the B part says find the power absorbed by the independent voltage source. This is the independent voltage source. Then we need to find the power absorbed by this independent voltage source. Let's do it. The power absorbed by this independent voltage source can be done as follows. First of all, we need to apply KCL at this particular node. When we apply KCL at this node, we know IS is leaving the node, so that is going to be positive. We know that I1 is entering the node, that should be negative, so we have IS minus I1. We do know that 2I file is also entering the node, that should be negative. So IS minus I1 minus 2I file equal to 0. If you rearrange that, it becomes IS equal to I1 plus 2I file. We do know the value of our I file to be 2. We know the value of our I1 to be minus 1 as calculated and given in the question. Then when we substitute both of those in the equation we have here for IS, it becomes IS becomes 3 ampere. So we have found IS. The current flowing into this circuit element to the voltage source is equal to 3 ampere. So it becomes easy then to calculate the power for Vs. In the previous question, we found our Vs to be 70. Now we found our Is to be 3 amperes with no power equal to IV, current multiplied by voltage. If you multiply those together, you will find 210 watt. So the power absorbed by this VS independent voltage source is 210 watts. In the C part, we were asked to find the power delivered by the independent current source. Where is the independent current source? This is it. Independent current source has 5 ampere, and then we are finding the power. First, we have to find the V1. How do we find the V1? V1 here will be the same voltage seen by this resistance because both of them are connected in parallel. If they're in parallel, the voltage V1 here must be equal to the voltage across this resistance. So if we can find the voltage across this resistance, it must be equal to the voltage V1, across this independent circuit element, independent current source. Therefore, we can say our V1 would be equal to 30 multiplied by I file, the current passing through this resistance. And that's what we have here. Our I file is 2, so V1 will be equal to 60 volt. Once we know that V1 is equal to 50 volt and we know our 5 ampere current, it becomes very easy to find the power that is delivered by this current source, and that becomes 60 volts, which is our V, multiplied by the 5 ampere current, and that gives us 300 watt. Total power delivered by this current source equal to 300 watt. Then the D part says find the power delivered by the controlled current source. Where is the controlled current source? Here is it. This is the controlled current source right at the top. Okay, so the first thing you want to note is that we know our I file already, okay, and that is 2 ampere, and we're going to use it at the appropriate time. Now let's go ahead. The voltage across this dependent current source is V file, as you can see here. Okay, so how do we find this V file? V file will be equal to the voltage that is seen across this 10 ohms resistance. The voltage across this 10 ohms resistance will be exactly the same voltage seen by this V file. Hence, we can say our V file will be equal to IR because we know that I multiplied by resistance is equal to the voltage. Okay, V equal to IR. What is our R here? It is 10 ohms. What is our I? Our I here is equal to, you will notice that the current is moving in this direction, and so the polarity or the sign of this current is going to be negative, because if we draw our closed path direction, which is clockwise, it is going to be going against the value, the direction of this current. This current I1 is going against the closed path direction, so I1 is going to be negative. With that in mind, the current path is going to be negative for I1. So our V file therefore will be equal to minus I1 multiplied by 10 ohms. If we do that, we know our I1 already from the previous questions, from the previous solutions. We know the value of our I1. We put it here. I think it's -1. If you put that here, it gives you minus times minus. And that gives you plus 1 times 10, and that gives you 10 volts. So the voltage across this current controlled dependent source is 10 volt. Once we know the voltage, we can then find the power. Power will be equal to current times voltage. Current is 2 I file multiplied by voltage, which is 10. I file is 2. If you multiply everything out, it gives you 40 watt. Total power delivered by this current controlled current source will be equal to 40 watt. And then the last question says find the total power dissipated in the 2 resistors. Total power dissipated in the 2 resistors. Okay, the power in the 2 resistors can be found as follows. We have to pay attention to the flow of current in the 2 resistors. Okay, the voltage across this particular resistor will be equal to, if our closed path is this way, the voltage across the resistor with I file here would be V1, as we know, multiplied by this current flowing here would be I file. So power here would be equal to V1 I file. And then the power on this particular resistor with 10 ohms would be equal to, since the current is flowing in this direction, we know that, and then we have 10 ohms here. All right, so the power here would be equal to, as you can see here, since current is coming this way from our closed path, the current is coming into this 10 ohms here, but the current I1 is going against the closed path that we have coming into this particular 10 ohms. So what we can actually see here, what we can actually conclude here, is that the power here would actually, be equal to IV where I will now be minus, we'll take a negative sign, multiplied by the voltage across this 10 ohms, which is V file. That is why we have minus V file multiplied by I1 here, where this minus is based on the fact that our I1 has a negative polarity. If you then go ahead and substitute all the values of these parameters in this expression, we know our V1 is 60 volt from what we calculated right up here. We know our I file is 2 amperes given in the question. We do know that our V file is given as 10 volt as calculated right here at the D part of the question. We also know that our I1 is minus 1 as we calculated in the previous part, in the A part of the question. So if you put all of those there, you have 60 multiplied by 2, that is 120, plus minus 10 multiplied by minus 1, that gives us plus 10. So 120 plus 10 gives us 130 watt. So total power dissipated or consumed or absorbed by these two resistors will be given as 130 watts. I want to believe that along the line it is possible that you have 1 or 2 questions. Please don't hesitate to put those questions in the comment section. I'm going to try to respond to all of those questions as much as I can. And if you have other concepts that you want to share about this video, don't hesitate to let us know what you think by making those comments in the comment section. This brings us to the end of our lesson for this session. I do hope you have enjoyed this particular teaching. I want to encourage you to go ahead and give this video a thumbs up if you like it. I also want to encourage you as much as possible to subscribe to this channel and click on the notification button so you can get updated videos even before the session days. See you in the next session.